WP-Get Web Dev tutorials for all user levels. Okay, so part 2 of my animating and triggering events in the viewport for Bricks Builder. So just to clarify, I'm currently using Bricks 1.5.2 and as today is the 19th of September 2022. So what I'm going to talk about may change as the versions increase. But from right now, from as far as I can tell, there is no way to trigger animations or events from elements entering or exiting the viewport with the standard Bricks Builder. Heading over to the code. So my code, which I have put in the description to a link to the GitHub. It's got a folder called Bricks, which has got all this in it. So at the moment, my code is made up of 4 things. So the first one is my Breakpoint CSS, and this is inspired by this URL up here. So this gomakethings.com. I think it's a brilliant way of checking what your viewport size is. Now, I don't know if Bricks has got built in some methodology to do this, but I could not see where that was. So if I look in Bricks, for example, if I look at the front end, look at my body and HTML, as I change the viewport, I don't see anything changing here to indicate what the viewport size is. There may be a JavaScript event or JavaScript method that I could call for the viewport, but I couldn't find any details on that. So I implemented my own. So what we've got here is a very simple way of doing it. So we're using a before pseudo selector on body. We're setting the content by default to be the word mobile, hiding it with display none and visibility hidden. And then all we're doing is at media breakpoint of 768 pixels, we change the content to tablet, and at 1025 we change that to desktop. And you could add as many of these, like we could add another one in there, for example, and make it at say 2400. We might class that as large. You can do whatever you like with this, and it's going to work for you. Let's just take that back out. So that's a simple CSS solution to adding basically a word on that pseudo selector at different breakpoints that changes. And then we have a JavaScript method. And this method basically gets the computer style from the window for the body attribute before pseudo selector. We get the content and then replace the quotation marks with nothing. So we end up with, from that, depending on what breakpoint we're on, we'll just end up with the word mobile, tablet, or desktop. So that's our breakpoints. I'm then, with all of my code, and so I don't pollute the window object, I create a object called _WPG. So on window, WPG, if it hasn't been defined, then create an empty object. And then down here on the window object, WPG, I'm going to add a breakpoints property, which is an object as a single property at this stage called getBreakpointName, which exposes the method or function, whatever you like to call it, breakpoint name. So there's a little hint down here. How you would access this anywhere else in the code is you'd call window.wpg breakpoints getBreakpointName, and that will return mobile, tablet, or CSS, depending on what breakpoint you're on. I think this is a really eloquent way of doing it, so that's what I'm going to rely on for now. Now, I'm only using this for where I've got conditionals to determine whether I throw events or apply CSS transitions, depending on what the breakpoint is. So that's pretty much the only reason I've got these two. So that's the first part. The animation and viewport. We went through this in the previous video, so I'm not going to go spending too much time in here, but that's the actual animations that we're going to apply to the classes. So we're tracking an element, and so fade and Y, the first child, this is our default state, or when we are out of view, that's the return state. When we're in view, then this is the state that we want to translate to. That's pretty much all we're doing in there. So I'm not going to go through that again. Let's say take a look at the animate in viewport code. So I've got a simple constant for debugging, and I'll show you what that does. If I set that to true and save that, and it's the wrong page. So let's go to the right page. It is. Whoops, I forgot to change that. Let's go preview and then view. There it is there. And you can see all of the stuff being echoed out to the console. So if I do a Control F5, so I've got my initialization, passing of all the attributes for the elements that I'm tracking, and these are all, this is dispatched as tracked out, that's dispatched as tracked in. When it's in, I'm getting the intersection observer entry. So the in was this target here. Okay, so we can actually see that's in the view, and the console is actually echoing out that is actually what is in the view with what actually happens. So we're intersecting, and an intersection rectangle, the client the bounding client rectangle, a whole bunch of information you can use if you want to. Now, this is interesting here, which we'll talk about in the initialization. So the root bounds of bottom and height, right, top, etc. That's for our tracking, which we'll talk about that a little bit later. All right, so that is basically debugging. We'll turn that off. Actually, we'll leave it on for this. I've got two variables here for collections of elements. One is the elements that I'm going to track in the viewport, and the other is the elements that I'm not going to track in the viewport. So I still want the same animation, attributes, and everything applied to both of these. But these ones here, I want to watch them as they enter or leave the viewport. All of the ones that are in this section here, I have to manually trigger based on some other event. Okay, we take a observer collection, and the reason I do that is because when we resize the screen, our mobile might change. Sorry, our device might change from desktop, mobile, tablet. So I want to initialize everything on a resize. So I'm going to use this collection. I'm going to remove all those observers and then reinitialize. Device mode is mobile, tablet, or desktop, pulled from those CSS breakpoints. Okay, so a couple of constants here. So the track element selector, so we want to use a class of VPA track. Non-track element selector is VPA no track. Initialize class, so once it's passed an element, we want to add this class to the element. Now we don't put the dot in there because when we add that using the JavaScript function, it'll add it as a class without the dot. But we do need the dot when we're looking for elements using our query selectors, etc. So what class do we want to add when the element is considered to be in view? What class do we want to add when it's out of view? And these will toggle. So when it goes in view, it'll remove the out of view class, put the in view one. When it's out of view, it'll remove the in view class and put the out of view class on there. The default top. This is using the browser intersection observer. So it takes only percentage or pixels, and minus 20 means it's minus 20 from the top and minus 20 from the bottom. It has to be a minus. If you go a positive integer or positive percentage, it's tracking it when it's outside the viewport, but we just want to animate when it's inside the viewport. So minus 20 from the top, minus 20 from the bottom, unless we set it otherwise. Track a view event name, the default name is track view. Okay, we wait for our DOM content to load, so we know that we've got everything we need to track, and we get a tracking element collection by doing a query selector all on the track element selector. Non-tracking elements, query selector all on the non-track element selector. And then we call our initialization function. And I probably should move this further up here in the code because I just realized it's all the way down the bottom. So if there's debugging, then we track our viewport in it. Okay, so that was the code that we saw here, where it's when the debug's enable, it's just passing out some. It's just console logging some information that we can see what's going on. Get the device mode. So remember this little function here from the window object, WPG, get breakpoints, get breakpoint name. That was in the breakpoint.js here. And then we want to pass the settings to element data and track elements for the trackable elements. Now, pass settings to element data. Go to that. That's the biggest function here. Again, some debugging. So what we're going to do is get all of the elements, so the tracked and the non-tracked elements. This is using a ES6 destructor to create a single array of both those. And then we iterate through each of those. We're going to create a conditions object, which we're going to store on the actual element. So the conditions are for the mobile. Do we want to add the CSS animations? It looks for the attribute to disable it. So if we add this attribute, it doesn't have to have a value, it just has to exist to any of the tracked elements on mobile, it will not apply the CSS animation. If we add this attribute to the tracked element, it will not throw JavaScript events. So we can control on mobile, tablet, and desktop whether we apply the animations and whether we throw the events. Okay, so that's what this is all for. And it's as simple as just adding an attribute to the tracked element if we want to disable any of these. All right, so it creates that. We then go through here, an event prefix. It will create our event names using the event prefix, in this case custom. It'll add the underscore, use our standard element, so our standard event name, and then /in. And then the same thing /out for the out event. So if you don't specify a event prefix, it's just going to fire this event for the in, and that's it, this event for the out. I like using the prefix because then you can have your listeners only looking for specific events. And it just makes a lot more sense than having to filter through in a single event listener. There may be cases where it makes sense, but and look for what actually triggered the event and whether you should do something with it. So the event prefix, if it exists, then get the event prefix and add the underscore. And we're going to create our name. So it's the event prefix with the underscore, the event name, and then /in and /out. So in, out, names. We create a settings object, which we grab our conditions from above here so we can disable or enable CSS or events on different breakpoints. Our event prefix, our in-event new name, and our out of view event name are our object. And then basically we stringify the settings and store that back on the element. So this is what we're passing. If we look at one of these elements, so there it is there, and we've got a VPA setting. So data-VPA-settings, and on that we've got an object here. I might just zoom in a little bit on that. We've got a object, doing a bit more. Here we go. So we've got a data VPA settings, which has a JSON stringified object, which has got our conditions for desktop, mobile, and tablet. It's got the event prefix, which we haven't put on this one, the event name, and the out event name. Let's go down to one of these as an example. So in here, I am using an event name. In the event name, the event prefix is track color. So it adds the underscore. So my in-event name is now track color underscore event. It's track color underscore track dash view /in. And the out is track color underscore track dash view /out. So we can pull this information from the element, which is actually going to be useful a little bit later on. Now, remember from the previous video, what I was saying is that when we're tracking an element, we don't want to animate the tracked element, because if we animate that element and it moves vertically up and down, it's going to move in and out of the viewport and re-trigger the events. So what we want to do is get the first child of the element that we're tracking, and that's what we're going to animate. So we need to be able to pass down all the properties that we set We're coming back to this example here. So on the, where are we? Our style, looking for our style. Class. And we'll go up to this one here because we know we've got some style attributes on there. So on here, we've got a style with a variable for our transform duration and our distance. Now, these do not propagate downwards in the DOM. The style attribute does not propagate downwards properly for these variables. I'm not sure why. So what I've done is, you'll see in the first child, I've got the same style. And the way I do that is by getting the first child, getting the attributes from the first child for the style, if it exists, then on the first child setting the attribute style for the same style. So that's copying basically, copying this style from that tracked element to the first child element so that those variables actually apply. So that's what that does. And then we basically add a initialized class list. So what that's doing is once this is finished, it adds this VPA initialized class. So whether that's in view or not, so let's take that out of the view. So this VPA initialized for this one here is now out of view, but we've got our VPA initialized because it's been passed. Once we bring it back into view, we've got the in view. So I haven't done this here, but what you can do is you can actually create different CSS states and your rules for when it's out of view. I've only done the in view. So what it's doing is returning, so it goes to a default state there, and then when it's out of view, it fades out like that. I mean, if I wanted that to spin off to the side and, you know, and scale up or scale down, I could also create a out of view rule which tells it to do that. Okay, but I'm not doing that in this instance, but it's that easy to do. All right, so that's pretty much what our pass settings to element data does. It just gets all the attributes, stores them as an object on the VPA settings, and copies the style attribute from the tracked element to its child, its first child. That's what the parsing is actually doing. All right. So back down to our init. Yeah, so we've passed settings to element data, and now we're going to track elements. So unfortunately, this loopy code box doesn't have anything to click on to go to these. So I'm just going to scroll up till I find it. Okay, track elements. There. All we're doing is getting our tracked element collection, iterating through those and telling it to track that element. So track element is here. We're getting a top, so from the data set IO top. So when you set the attribute of data IO top equals say minus 40%. What this data IO top translates to from HTML into JavaScript is dataset and then camel case, removing the dashes. So dataset IO capital TOP is exactly the same as that. So that's what we're actually doing there. So we get the top if it's set. If it's not set, we use our default top, which is minus 20%. Same with the bottom, and we create our root margin string, which would be by default 20%, 0 pixels, 20%, 0 pixels. We're not worried about horizontal tracking, just vertical tracking. Then we have a settings or configuration object here for our intersection observer. And setting the root to null means it's tracking the entire viewport. That's all we want to do. You can actually get another DOM element, position it absolutely, and stick it in the center of the screen and use that as your reference for tracking. That's another way of using the intersection observer. We don't need to do that because we just want to know when it comes in or out of view and how far from that it is. Entire viewport, using the root margin, by default of -20 top, -20 bottom. And the threshold. So the threshold means only point, in this case, 0.00001 of the tracked element has to be within the viewport, within those margins, and it's considered to be inside the view. If any of that, if all of that element is outside of that viewport, then it's outside of the view. If you set this to 1, then the whole element being tracked has to be within inside that tracked range. So if we got -20 from the top, -20 from the bottom, so we got 60% left. So it's got to be, the whole element has to be within that 60% of the vertical height from the center. Otherwise, it's considered to be out of the view. If you set it to 0.5, at least half of it has to be within that section, track section. Otherwise, it's considered out of the view. I like to leave it as a very low number, so any part of that object is within the tracked viewport range, and it's considered to be inside the view. All right, so we've got our settings, and what we're doing now is set up an observer with a callback, and this callback has the entries, so an observer can track multiple elements. We're only using this to track one element, so every single element has its own observer. And the reason we're doing that is because on every single tracked element, we might have a different top and bottom setting. If they're all exactly the same, we could actually just have one intersection observer and add all of those elements to it. But we want to be able to control where they're tracking in the viewport, so we have to have an intersection observer for every single element. Passes in entries and observe. So entries is all of the elements that is being tracked by that observer. Iterate through them. If the entry its intersecting property is true, then we want to set that element as being in view by calling our set in view and send our entry to it. Okay. Otherwise, set it as out of view with the same properties. Now, if we go back to our console where we're logging out, so when it's in the view, what we're doing is we're actually setting this intersection observer entry. So here's our intersection is true, and here's our target saying which element actually triggered this. Then all we're doing is setting in view or out of view. We'll come back to that in a second. Then we're telling our observer, once this observer is set up, we're telling our observer to observe that element. And then we're adding that observer to our collection. And the reason we do that is because up here, further up here, we've got a resize event. And what we want to do is we want to go through every one of those and disconnect them. Okay, that removes the intersection observer. So when we resize, our properties might have changed depending on whether it's breakpoint on mobile, tablet, or desktop. So what we're going to do is just basically remove all those observers, reset the collection, get our device mode again, and then retrack the elements. So recall that track elements. I mentioned down here we've got a set in view and set out of view. So the set in view takes the element we want to say is in view. If the intersection observer entry element is provided, then we want that as well. We want to then get our settings that when we pass the initial elements, we saved all of our settings into an object called VPA settings, data VPA settings. So we want to get that, and we want a JSON object from that. So we want to pass that JSON object into an object. And we're using an ES6 destructor here to, from our settings, we want our conditions, our event prefix, in event new name, and out view event name. And then here's the interesting part of one of the reasons why we do this. So if the conditions open brackets device mode, so mobile, tablet, desktop. So if we look here, get one of these. We look in here, so we've got our conditions, mobile, tablet, and desktop. We're looking for whether we want to have CSS events and whether we want to have, CSS transitions and whether we want to throw an event. Okay, So that's why we stick it on there. And then we can pull that off here. And if our current breakpoint is mobile and the events is true, we want to dispatch a event with the entry. Okay. If it's not true, then we don't dispatch the event. Same with the CSS. If the device mode, say for example, is mobile and the and CSS is true, so this here, CSS is true, then we want to remove the add the in-view class and remove the out-of-view class, right? And set out-of-view is basically doing the same but opposite. Okay, so it is dispatching an out-of-view event name. It is removing the in-view class and adding the out-of-view class. Then expose these methods so that we can manually trigger them. So remember we said we had trackable elements and non-trackable elements. So the non-trackable elements, we want to be able to trigger those to be in view or out of view, so we can get our animations or events thrown. So how we do that is down here further. So again, I use a single object on the window. If it's undefined, I define it. And then I add my viewport animation property. I expose two properties, which is set in view, set out of view, and expose those two methods. So now I can call those by just calling window by anywhere. If I do window dot set in view, so DOM element, that is going to tell that element to set its, going to tell that element to get its properties from the from that VPA settings, and it's going to throw an event and add the CSS for the in view. All right. Oh, one other method I'll just mention here. So when we set our in view and out of view, we're calling a dispatch method where we're setting a event name and the entry. What we're doing here is we're creating a new custom event. So the event name, whether it's the prefix with track view /in or track view /out. The detail property, so custom events in JavaScript have a detail property, and we're passing the entry from the intersection observer as the value for that detail property. So we end up with something we can track. And if we look at this, for example, this is one of our examples from the previous one. We're looking at track color, track view in, with the event being the E, and that is an entry object. If we look over here, we look at the console, entry object, intersection observer entry, which has all of these properties. So we can see a lot of stuff about where it intersected, what the target was, when it intersected. You can use all this in your JavaScript to determine what are you going to do with that inside that listener. So that's pretty much the code explained. It's not overly complicated. It does require a little bit of an understanding of JavaScript, but it's not overly complicated. One thing I'd like to look at is, at the moment, I'm requiring the Breakpoint CSS and JavaScript files. And the reason for that is because I don't know whether Bricks has a method for being able to detect that. If it does, then I can remove those two dependencies here and update this code to use the Bricks method. So if anyone knows of a method to do that, then let me know. So I'd appreciate any feedback we can get on that. So that's pretty much it. And I hope that explains the code and gives you something to work with, and happy creating.